redirects?
No,
it's like a lightning shield or what?
No, you can put a shield around the computer like a Faraday cage. It basically limits what kind of frequency can get in and out of your the environment. Yep.
If I'm ever in an area where there's the ESP, I think the computer's the last thing I'm worried about. So.
Well, that's why the military use kind of dated hardware or processor chips because they need hardened chips, what they call hardening. They need to harden the chip to make it withstand nuclear blast within a certain distance.
I mean, they could like subcontract somebody else out to build something that's just as advanced with the same kind of resistance.
It's expensive. Yep.
Or when our budget's like $1 trillion for
they may stall.
Right.
Alright, well, let's go ahead and get started. So we're going to work on return values today, which is the very last topic of subroutines. Okay, so after this, you're good with subroutines, and we can I should give you guys a homework assignment too. So let's go ahead and get started with the return values. Last time we talked about infix, which means the usual way of writing expressions. We talked about prefix, which is kind of like a subroutine call. You use the name and then you supply the values that it has to work on. And then we talk about postfix, which is really awkward way of using a calculator, but nonetheless it is used because earlier calculators lack the complexity to handle parentheses or the infix notation. The infix notation may look natural to you, but to a calculator, it actually takes quite a bit of processing or parsing in order for the computer to understand what you mean when you say 2 times 3 plus 1, because in that case the order of operators is also important. Okay? All right. So now we are going to talk about return values. We'll start with an example that is really easy, and then we'll increase the complexity as we go on. This is the note that it is coming from. So when you go to the class site, you go to topic number 9, and I would use the updated subroutine notes because that really is a better summary of all the things. But you can also go to returning values from a subroutine. They're basically the same thing. It's just that one is more up to date or in terms of the representation of the concepts. But in a class, I always just use examples to illustrate the concepts. So we'll go ahead and use a very simple program to illustrate that concept. Okay, so we'll create a folder first to save the file.
You haven't set a date for the next exam, have you?
No, have not set a date yet. I think I will finish this topic first, and then we can have the exam.
If you were going to ballpark it, like, would it be this month or this month?
Oh, definitely this month. Probably within 2 weeks or so. All right. So I'm going to write a very simple subroutine. So I'll just say define sub. Give it a really kind of obscure name. So we'll just call that okay, XYZ. Okay. And the only thing it does is a return statement, which is a statement that we have not seen up to this point. Okay. So we'll just return a value. We'll make it return a constant 5. Okay. And define sub. So this is the only thing this particular subroutine does is to return a value of 5. And then using our new convention, we have a main subroutine that will invoke from outside of the subroutines. And in this case, what we'll do is we'll have a local variable. This part is actually not that important. We'll have a local variable x, and x will get the result of invoking xyz, and define sub, and then outside of the subroutine, we just invoke main. So that's the entire program. And this program, the only purpose of this program is to illustrate the concept of what does it mean when we return a value from a subroutine. Now, from last Thursday, I gave you a little preview of what it means when we return a value. When we return a value from a subroutine, it means the invocation of the subroutine can take the place of whatever the return value can go. In this case, it's returning 5. 5 is an integer, it's a number, it's a numerical value. So that means invoke XYZ can now go anywhere that you can specify a number. Inside the comparison, no problem. On the right-hand side of an assignment statement, no problem. Okay, just basically anywhere that you can expect a number 5, you can now put invoke XYZ in place of 5. Okay. So even though we know what the purpose is and what it can do, let's go ahead and look at the trace, because this is where the tracing can get a little bit complicated. But I think the complexity is necessary to explain the concepts. So we'll call this file return value 01. Okay, so depending on how many of these sample programs we can go through today, we'll just go through the numbers. All right, let's go ahead and trace it. We don't need comments in this case because there are no conditions to evaluate, so we start with line number. There are no global variables whatsoever. In other words, we have successfully removed all references to global variables up to this point, which is good. The first line that is outside of the definition of a subroutine is line 8, which its only job is to trigger the execution of the main subroutine, just like in C. On line 8, we have to do the usual things that we have to do. We have to remember the return line number, as well as allocate one column for the local variable x. As a local variable, it always starts with an unknown value. And the return line number is post because there's nothing after the invocation of main. And then we continue execution inside the subroutine. Inside the subroutine main, line 6 is the first line that actually has something to do. Now this time, when we set up the return, the information that we need to come back, it has to be a little bit different, because if we say return line number and returning to line 7, that means we're going to skip over the assignment portion, because when it returns, we have simply resolved the value of invoke XYZ, but it still has not been copied to the variable x. On the other hand, if we say we are returning to line 6, we're going to do the whole thing all over again. So the whole concept of just remembering which line to come back to is no longer sufficient. Okay, so I'll say that again because this is really important. When we can use return line number for main, we can no longer use just return line number for XYZ. Because when XYZ is done, we are going back to line 6 to finish up what is left on that line to do. Because on line 6, there are two things to do. One is to invoke the subroutine XYZ, figure out what is the return value. The second thing we have to do is to finish up the assignment to copy that value to variable x. So that means when we come back to line 6, we have to say, oh, we're going back to line 6, but when we do get back to line 6, this is what we need to do. This is what we need to finish up on line 6. And that's why in terms of the labeling, I'm no longer calling this return line number. I'm calling this return info, or information that I need to do the return. Okay? So this is the first kind of superficial difference between a return line number and a return info. But what I put here is also going to be quite different from what we usually do, because what I'll do is I'll say, yes, we are going back to line 6. But when we're going back to line 6, this is the rest of the operation. We have the assignment done, and the invocation itself is replaced with a question mark, because that is what we are resolving when we get to subroutine XYZ. Are we doing okay so far in terms of the rationale of this representation? The actual representation is not as important as understanding why we are representing it this way. We have the assignment left to do on line 6, but we are going to resolve the question mark right now. Okay, we want to figure out what is the value that we are copying to variable x. The rest is about the same. If I had any local variables or any parameters in XYZ, I would still have to allocate additional columns. But since in this case, XYZ does not have local variables or any parameters, I do not need to allocate any additional columns. This is how we set up the return info for XYZ. Once it is set up, we can continue execution inside XYZ, which only has one line that is really useful, which is line 2. So what do we do when we say the subroutine is supposed to return a value of 5? Well, what do you think? 5 is going to take the place of the question mark. Okay? In other words, the question mark is a placeholder for a return value. When we invoke the subroutine XYZ on line 6, it is question mark because we don't know what it is. That's the whole purpose of invoking the subroutine. By the time we get to line 2, it is saying that, oh, you know what, as a subroutine, I'm going to return a value of 5. So what we do in this class is we copy and paste the return info cell, and then we change the question marks to the value that we are returning. In this case, it is simply 5. Are there any questions about what I just did on line 2? First of all, do we understand the rationale, what we are doing here? We are resolving the value of the subroutine, okay? And that's why we are replacing the question mark with a single value. But we do not change anything about x. This is not the time to change variable x. A return statement is responsible for one thing and one thing only. Go to the return info cell, change the question mark to an explicit value, and you're done. Yep.
So what we're doing here is basically creating subroutines within subroutine before we actually execute the main program.
We do have a subroutine inside the subroutine, or a subroutine that's invoking another subroutine, yes.
Okay.
But that's not the main point of this particular program. The main point of this particular program is to illustrate what does it mean when we have a return value inside the subroutine.
I'll figure this out in a few hours.
Sorry?
I'll figure this out in a few hours.
Okay. Okay, on line 3, we do the same thing as we usually do. Now this time it gets a little bit more complicated because the return info tells us to go back to line 6. So the usual way of doing things is we just put a line 6 here and say we are going back to line 6. Now this part depends on how you want to do it, because one thing you can do is not just to go back to line 6, but you just copy and paste the entire return info cell. So this way you're not only remembering that you're going back to line 6, you're also reminding yourself, when I do get back to line 6, what am I going to do? Okay, so it's up to you, because I personally would just say going back to line 6 and then go back and refer to column D to figure out what else I have to do on line 6. This representation is more clear, but it does take up a lot more width when you have a long line on line 6. So it has trade-offs, but for this particular example, it is more clear that we indicate exactly what else we have to do when we get back onto line 6. The other thing about return info which is the same as just returning from a normal subroutine, is you still have to deallocate the column when you're done with this particular subroutine. In other words, what we talked about earlier, whatever you allocate for an invocation, you have to deallocate. That applies the same way with a subroutine that returns a value. Okay, now that we are back onto line 6, line 6 is now x and gets a value of 5. We just update x at this point because now we are executing line 6, or finishing up the assignment portion of line 6. So C is now updated to a value of 5. And now that we are done with line 6 altogether, we move on to post, and we're done. Are there? Sorry?
Don't you have to go to
Oh, yes, we have to go to line 7. Sorry. Go to line 7, and then it looks up the return line number. We are supposed to go to post next, and then we can deallocate it. Thank you. I forgot about that. Okay, that's the right trace. There we go.
Yep. Also deallocate X too.
Yes, we do. Whatever we allocate, we have to deallocate. All right. Any questions about this particular trace? Yep.
So when you go inside of a subroutine that has a return value, then you just have to have a return info column, basically, when you trace.
Because
Yes, and then the return info column, it's both having a return info column and also what you do with it that is important.
So the return info is what goes back to whatever line invoked the subroutine then. For instance, like in this case, 6 invoked the subroutine, and X gets the invocation of that. So if your invocation of your subroutines on line 6, which is where your return value is going to go to the variable that's stated there or whatever, then that's what goes into return info.
No, well, the return info just has a question mark when it is invoked. So the return info has a question mark to represent where is the return value going into. When you execute the return statement on line 2, in this case, you change the question mark to 5 because that's the value that we are returning. We have just resolved what that unknown is supposed to be, but we do not carry out the assignment operation on line 2 because its only job is to replace the question mark. But to utilize the question mark is the job of line 6. And that's why we don't do it until we get back onto line 6 of row 9 in the trace.
Is that why line 6 is listed in the return info?
That is correct, so
Okay.
that we know
That was
where we're.
that was my question.
Yeah, that's because we used to only have return line number, which is just 6. But what on line 6 are we going to do is missing. And this is how we keep track of what we are supposed to do on line 6.
And this is the only one where you get like a return inside the subroutine? Or is there other cases? Or
Return only makes sense inside the subroutine.
No, I mean, you only use return info or read.
Yeah, return info goes along with the use of a return statement inside the subroutine.
Okay.
Yep. If a subroutine does not have a return statement, you can still use return line number or return info, but it will be like the next line, the entire next line, which means you can just use return line number, which is a shorthand of return info of the next line, the entire next line.
Thank you.
So this is a more general way of doing things, but it is more cumbersome in a way. Yep.
Is return 5 completely unique to the invocation of XYZ? Like,
What do you mean
can
by-
it ever be accessed from another invoked statement?
You can invoke XYZ from any place, but anytime you invoke XYZ, it will still execute line 2. Am I answering that question?
Kind of. But
Kind
it's
of.
okay.
Okay. All right. Any other questions? Yep.
So there has to be somewhere for that return value to go. 'Cause it can't-
Technically, yes. In C and C++, you do not need to have a place for that. In other words, you can just invoke XYZ all by itself in C, which means the return value is just, it's just wasted. Okay, nobody cares. Okay, so that's okay in C and C++. But when you invoke a subroutine but not do anything about its return value, that is indicative of negligent programming because you're ignoring the return value. And the return value of a subroutine is almost usually useful.
Almost usually.
Almost usually useful.
So it's sometimes not.
Sometimes, depending on your program, if you make certain assumptions about the input, maybe you don't have to deal with the return value because you can assume, okay, I'm reading this file, but I know for sure that I will not be at the end of the file at this point. Okay, then you can just kind of ignore the return value, which may tell you whether you are or you're not at the end of the file. But usually a good program will make use of the return value every single time you have a return value.
Otherwise, it's pointless.
Otherwise, you're ignoring something, an extra piece of information coming back from the subroutine, which is usually not a good thing.
Knowing you have to be very particular in how you sort of collect the return information. Is that the same with Perl and languages?
In other programming languages, I would say this model is still true.
Okay.
This applies to Perl and PHP as well, the way it returns a value. Yeah, this is not internally, it doesn't go through all this trouble, to copy and paste a whole bunch of stuff. Internally, it is really just, the subroutine just fill in a particular spot, or a slot, and then the invocation just makes use of that information after it returns. So it's actually a lot more efficient when it comes to the implementation inside the machine But in terms of the representation that we can see and visualize, this is the best I can come up with for a class like this.
Because I know in Visual Basic you have to like return it, but you have to collect it as like a string or whatever you're collecting. Is that the same with VB? You have to, or same with like Perl?
What do you mean by collecting?
Like when you receive the information from the subroutine, you have to specify which variable type it is.
Oh, okay, so you have a typed return value.
Yeah.
That part has to do with whether the programming language is a strongly typed language or not. And there are, okay, just for the reference, C and C++ are considered strongly typed, so it would be the same as a VB program, where instead of just saying sub XYZ, you have to say sub XYZ returns an integer. Then that will help the compiler to determine where invoke XYZ itself can go. In VB, you can crank up the type strength, so it can make it strongly typed, or it is strongly typed to begin with. In PHP and Perl, they are not strongly typed languages, which means the value, the numerical value 5 and a string 5, okay, using the digit 5, doesn't make any difference until you get to the operator. So when you have a multiplication operator, it would take the numerical interpretation. When you go to a string operator, it would use the string interpretation of 5. So that's kind of one of the aspects of Perl and PHP, both being basically text processing programming languages. VB is kind of general purpose, and C is a system programming language, so type is very important in C and C++ programming. So at this point, we are kind of ignoring all that stuff, because up to this point, we are just assuming that most of the numbers or most of the types that we deal with in this class are integers. So we'll talk about types when we get to records, because that's really when we need to be conscious about, okay, we have to be aware of, are we dealing with integers, booleans, or whatever. Okay, but up to this point, we can just kind of be a little bit fuzzy about the type. So are we doing okay so far with this program? Okay, if we're okay with this one, I'll save it first, and then we'll start with another program. We'll just go ahead and close this one. Go. Start with a new one. The new one is not going to be that much more different. I would say define sub ABC. It returns a value of 3. Define sub XYZ, and it still returns a value of 5, just like last time, and define sub. And here's my main subroutine. Define main, define sub main, local x, just like last time. This time I will do something like this. How about invoke ABC plus invoke XYZ? So this program is very similar to the previous one, except on the assignment line, we have 2 invokes on the right-hand side. So the question now is, how do we keep track of 2 invokes on the same line? Yep, go ahead.
I just want to check, make sure you're recording.
Then I'm recording. Yep, it's recording, and it's recording from the right channel. Because sometimes if it's recording from the wrong channel, then you get a silent movie. Yep, go ahead.
This is the answer to my question.
Oh, okay. So this trace is going to be a little bit interesting because, well, it's both interesting and not really interesting, because we really are not changing the way we are doing things. So from that perspective, it should not be interesting at all. But it may surprise some people, how this is done. So we go ahead and take a look at the trace. As usual, we have line number. The precondition doesn't have anything to specify because we do not have any global variables. On line 11, we invoke main. This part is the same as last time because after we return to line 11, there's nothing to do. So the return line number for this invocation is going to be post. And the subroutine main has 1 local variable x, so we'll allocate 1 column for x as a local variable. And it starts with an unknown value. No problem, same thing as last time. We move on to line 9. So this time the question is, how do we keep track of two invocations on the same line? Well, the thing is, we deal with one at a time. Okay, so that's the most important part is you can only do one invocation at a time. So in this case, when we first encounter line 9, my inclination is to read from left to right. So we'll handle invoke ABC first. Yep.
Does that kind of lead into interrupts at all?
Interrupts is a kind of like a completely different concept. In a way, it is invocation. It's almost like in the case of interrupts, the rest of the class can kind of ignore this part of the conversation. An interrupt is kind of like a hardware invoking a subroutine. Okay, in other words, your network card, says, okay, I need some attention. I just received a packet. Okay, so it's your hardware, your network interface card, calling the subroutine inside the operating system and say, hey, I just got a packet, you decide what to do with it. Okay? But it's completely transparent to whatever program the computer is running at a time, because it also uses the concept of returning, so it returns back to wherever the invocation interrupted to begin with. So getting back to line 9 here, we know that we have to use return info because both ABC and XYZ have return values. So when we invoke those particular subroutines, we have to use return info because when we return back to line 9, we might have some other things to do on line 9. So in this case, we are returning back to line 9, and because we are reading from left to right, I would deal with the first invocation first. So the first invocation or invoke ABC is the one that gets replaced by a placeholder because this is what I'll deal with first. I'm invoking ABC first. What about the second one? You know what? If I'm not dealing with it right now, I'll just copy whatever it is because I still have to do it when I come back on line 9. Is that concept okay? I'm quite impressed by the tiny little speakers on these mobile devices. It used to be extremely tinny, right? I mean, like a Nintendo, like really artificial kind of sound. But now they are pretty good. Even with the mid-range, it's still pretty good. I think one of these days you can carry a sub in your backpack, so you can get the sub portion also done right.
They're actually developing like three-way speakers for mobile devices. Right now, it's just currently a mid and a bass come.
Well, I mean, that technology has come a long way, the speaker technology. All right, so this is the most important part is to remember you should only have one single question mark in the return info cell, okay? Not two, only one, because we can only handle one invocation at a time. So in this case, we're dealing with invoke ABC first, and that's why that particular invocation is replaced by a placeholder because the next line I'm going to is that particular subroutine, so we go to line 2 in this case. Do we have any questions up to this point? No questions? Okay. So whatever is left on line 9 to perform, we just copy it when we get to this cell. Because it is operations to be performed, and I'm not dealing with it right now. I don't care about it, I just copy and paste it. Line 2 is a return statement. So what it will do is it will look up the return info cell, which is our column D, copy and paste it, because when we're tracing this by hand, we have to kind of go through all this trouble, and replace the question mark with a value of 3 in this case, because line 2 says return a value of 3. And that's all we're doing. We are not doing anything else about X or the other invocation. We are just replacing the question mark with the value that we are returning. We get to line 3. Line 3 is a typical end of subroutine. We have two things to do. One is to look up the return info cell in this case. We're supposed to go back to line 9, okay? I personally would just put a line 9 here and then just look up to column D to find out what else we have to do on column D, when we get back onto line 9. But for the first few times, what I'll do is I'm going to copy and paste the entire info cell, return info cell, just so that it is clear what else are we doing when we get back onto line 9. Yep. But at this point, back to line 3, the other part of line 3 is we have to deallocate the column that we allocated for this invocation. And now we can actually continue execution on line 9. But line 9 doesn't look like the original line 9 anymore because the first invocation was already done. We know it resolved to a single value of 3. Now it's time to resolve the second invocation. So that means we are invoking the second subroutine, which is XYZ. So once again, we have to reallocate a column for return info. And this time we have to remember, when we go back to line 9, the first part is done already, so we keep the 3. The second part is now, we are invoking this particular subroutine right now, so we use a placeholder to replace the invocation itself. And then we go into the subroutine. The subroutine XYZ starts on line 5, so we continue execution on line 5. Line 5 is also a single return statement. It is returning a value of 5. So what we do is we copy and paste the return info cell, change the only question mark to 5. In other words, at any particular time, a return info cell should have 0 or 1 question mark. It should never have more than 1 question mark. Now that it is resolved, we go continue execution on line 6, which is the end of XYZ. So we have to do the same thing as last time. We look at the return info cell. It tells us that we have to go back to line 9, but those are the only things remaining to do on line 9. So I just copy and paste this over here, and then we can deallocate the return info column, and then continue execution on line 9. Line 9 does not have any additional invocations. We can actually carry out the addition and then the assignment operation. The addition gives me 8, and then we have to copy that to variable x. So x is now updated to a value of 8. Then we move on to line 10 in this case. Line 10 is the end of a subroutine. We look up the return line number. In this case, we have to continue and post. And then we have no use of column B anymore. And column B and column C, both. We allocate those. And then we move on and continue execution at post, which means we are at the end of the entire trace. Are there any questions about this trace? It is consistent with the previous one, but with the extra twist of, but what if we have multiple invocations? Are we still doing okay? Yep, go ahead.
If you were to invoke something, say in ABC, before you invoked XYZ, would you make a new column right there? So you
Yes.
attack that first?
Yep.
You also said if we had local values in ABC or XYZ, we have to create those also.
That is correct. So the invocation of ABC and XYZ, for the most part, is the same way as all other subroutines. It's just that when you invoke ABC or XYZ in this case, instead of a return line number that only tells you which line you're going back to, you need a return info so that you're not only going to a particular line, but it will also tell you what else on that line you have to perform, when you get back onto that line. Yep.
We deallocate x, doesn't that get rid of where the variable is stored? Or-
That is correct. In other words, this program has no observable side effect. It doesn't print anything, it doesn't do anything, so we can only see the effect of this program through the trace, but if you were to run this program without a trace, you would not be able to observe it.
So how do you make it observable?
Print. You can print out the value of x, or you can print, invoke ABC plus invoke XYZ.
So print x would come after it and define sub. Like
Or
it
you can
does.
just print invoke ABC plus invoke XYZ without even x.
And that
because-
just comes after the definition of the main sub, the sub.
Correct, yes. So you can replace lines 8 and 9 by a single print to make the program observable.
So when you say print x, then does x get deallocated in that case?
No, printing does not deallocate it. It simply prints whatever its value is to the output of the program. Hmm?
So you wouldn't need X.
So I would not need x if I use print. Right, correct. So are there any questions about this particular trace and this particular program? The questions? This is all good? Okay. Let's save it. And we'll call the return value 01, 02. Return return value 02. And now we can move on to 03. Okay, so this time we'll have ABC the same way as last time. So define sub ABC, return a single value of 3, and define sub. And this time we'll define another subroutine. Well, I want to call it XYZ. Yeah, let's just call it XYZ. And this time it has a by-val parameter. We'll just call that n. And it returns n times 2. And define sub. And then we have main. Define sub main. And just like what we talked about earlier, instead of using a local variable to store a value, we're going to print out the value of an invocation directly. So we don't need a variable to store the value. So we'll print invoke. And this time this will be a little bit interesting because it has an invoke inside the invoke. They're not next to each other. The one is actually inside the other one. Invoke ABC will supply the value for parameter n. Oops, I kind of messed up here because I have to say invoke XYZ. And then inside that, I use invoke ABC to supply the value of parameter n. And run sub. Main. So that's the entire program. You can see that this program doesn't really have a lot of stuff to do, but the tracing of it can be interesting. It's interesting in a way, but it's also kind of boring in another way. So let me save it first. There we go. All right. So this program seems to be quite different from the one before, but you know what? When it gets down to actually working on this one, it's not really that different from the one before. Okay. So line 9 is really the issue here. How do we deal with line 9? Okay, the other ones we kind of know how to deal with already, but line 9 is the one that is kind of troublesome. Let's take a look. There's nothing to say about the precondition because there's no variables of any kind in this program. Now we do have one parameter. We have parameter n in XYZ, but otherwise we do not have any global or local variables whatsoever. So there's nothing to say about the precondition. We start execution on line 11. Line 11 is invoking main. Main does not return a value, so return line number is fine, indicating that we have to continue execution at post after main returns. So this stuff is pretty much the same thing as last time. When we get into main, the first line that is actually useful or do anything useful is line 9. Now we have to say, how do we deal with line 9? If you just look at the ordering in the parentheses, it would tell me that the first thing we have to do is to invoke ABC, so we can figure out what is the value of ABC, invoke ABC. Whatever that value is, we use it to specify parameter n, then we can invoke XYZ. So that's the second thing we do, is to invoke XYZ. After XYZ returns with a value, that is the value that I'm going to use for printing, so I'm going to print that value out again back onto line 9. So we're going back to line 9 a few times, okay? This time it's going to be about the same as last time, but the ordering is a little bit different. So this is the first time. What should I do first when we get to line 9 the first time? Can I do the printing? No. Can I invoke XYZ? No. The only thing we can do is invoke ABC. Okay, very good. So if the only thing we're doing is to invoke ABC, that will be the only thing replaced by a single question mark. So that's why I'm just copying and pasting the entire line the way it is, except for invoke ABC. That's the only thing I replace with a single question mark. Is that consistent with what we did last time? Oh, returning false. Call. Yep. labeled. There we go. So, but is that consistent with what we did with the previous program? Yeah, it is. Okay, because we are just focusing on one invocation at a time, and whatever we're invoking, we replace the invocation with a question mark. So it's basically the same thing as last time. Okay. Well, that's okay. We know how to deal with ABC. ABC starts on line 2. It returns a single value of 3. So we copy and paste the return info cell, replace the only question mark with the value that we are returning on line 2, which is 3. And then we are done with the return statement. We continue on to line 3. Line 3 has 2 things to do. Look up the return info cell. And at this point, we'll still copy and paste the entire return info cell so we know what else we have to do when we get back onto line 9. And then we can deallocate this particular column. And that's the end of line 3. Now we are getting back onto line 9. What do we do now that we are on line 9 again? We invoke XYZ, all right, because that's the only thing we can do. We cannot print yet. So now that we are invoking XYZ, we have to reallocate the return info column. And this gets a little bit tricky because I'm running out of column space. So this time, after XYZ is done, I still have to go back to line 9 because whatever it returns, I have to print it. So that's the only thing we have to do is to print out whatever XYZ is returning. But I have one extra column to allocate in this case because XYZ expects one single byte value parameter n. And once again, I forgot to label this one. So, oh no, I did. Okay, n goes here. Yep, just wrong row. Okay, n has a value of what? 3, exactly. Now we have 3 here. After we set up both columns, we can now continue execution inside the subroutine, which is XYZ. It starts on line 6. So we put the line 6 here. Line 6 doesn't really do much. It's returning the value of n times 2. N has a value of 3. 3 times 2 is 6. So we have to copy and paste the return info cell, change the question mark to the value that we are returning, which is 6. And that's the end of line 6. After line 6, we have to continue on to line 7. Line 7 has 2 things to do. One is to look up the return info cell, and it reminds us that we have to go back to line 9, and that's the rest of line 9 to perform. And then the second thing we have to do is to deallocate the return info column. Just like that. Now we are continuing execution on line 9. Now in this class, the only way to track the output is to use the comments column. So we just use the comments column. When we execute line 9, we just say it's printing a value of 9. 6, sorry. I'm looking at it with 180-degree rotation. And that's all that is left to do on line 9. So after line 9, we continue on to line 10. Line 10 is the end of the main subroutine. We look up the return line number, which is post. We say we have to continue execution at post. And then we have no use of the return line number column anymore. No, not delete. Strike through. And then we move on to post. That means we are done. Yep.
On line 7, you need to deallocate n.
Yep, deallocate n. Keep forgetting that. Yep. Go. Very good. Right. So are we feeling a little bit more comfortable with returning a value from inside the subroutine? What if inside XYZ it is invoking somebody else? Well, we do things pretty much the same way.
And then returning back to the line inside the subroutine.
Yep, which is okay. It works out the same way. Well, we already have a subroutine returning into a subroutine because main is a subroutine now. Yep. So I think we are ready to revisit Factorial one last time. So this time we'll look at Factorial again, but using the best implementation. This is the most efficient implementation of Factorial using recursion. Right. Let's take a look at define sub Factorial. We have one by-value parameter that we call n. If n is greater than 1, then we have a single return statement, which is n times the invocation of Factorial using n minus 1 to specify parameter n, else return 1, and if n define sub, and then we just go to define sub main, print invoke Factorial 3 goes to n, and define sub, invoke main, and fix the indentations. The line numbers. All right. Now this one does get a little bit complicated or kind of confusing because on line 4 we have an invocation inside the return statement. Okay. Well, if we do things mechanically, this is okay. It's actually not as confusing as it seems. But if we try to overthink this a little bit, then it gets really complicated and confusing. So we'll go ahead and give it a try, and then when you guys have questions, just stop me so I can explain the concept in a different way. So let's save it. Save to today's folder. And this one I have a definite name for that. We'll just call it Factorial. I made the grep border too thin, so it's hard to get to it. Start on sheet 2. We do need comments in this case for both the printing and also the conditional statements. Line number, no global variables. We start on line 12. Line 12 invokes main, so we need a return line number. Line number here. Remember, there's nothing after invoke main. Pretty typical stuff up to this point. Once we get into main, we start on line 10. Line 10 is a print statement, but it also has an invoke in it. And whatever is invoking Factorial returns a value. So we have to use return info in this case to remember that we are supposed to come back to line 10 to finish up the printing once Factorial is done with what it is supposed to do. And since we're invoking Factorial, it has one by-value parameter n, which is 3 in this case, because we have this 3 in the invocation. And after setting up these two columns, we can continue execution in the subroutine, which is Factorial, starting on line 3. Do we have any questions at this point? Up to this point, it's pretty much the same thing as what we have already dealt with. So, it's okay up to this point. Line 3 is not complicated. It's just checking the value of n. N is greater than 1 is true, so we have to continue execution on line 4. So line 4 now looks a little bit complicated. What are we going to do with line 4? Well, remember, line 4 can be very complicated. We just have to figure out what do we need to do first, and then what we need to do after that. So what do you think? Can we do the multiplication right now? No. Can we do the return? No. So the only thing we can do is to invoke Factorial again using what I already know as n, subtract 1 from that, and then make that the new parameter n. That's the only thing we can do at this point. So that's what we'll do. So we're invoking Factorial again, which means we also have to allocate an additional column for that invocation. It is still a return info because as long as we are invoking Factorial, it returns a value, and we need a return info to deal with it. When we come back from that Factorial, which line are we coming back to? The invocation is on line 4, and there are additional operations on line 4. So when we come back, we will still be on line 4 because the return operation is not done yet. The multiplication to n is not done yet. The only thing we would have done is to resolve the value of the invocation. So the invocation itself is replaced by a question mark. But to do any type of invocation to Factorial, we have a by value parameter n. This time it is 2 because it is 3 minus 1. Are there any questions at this point? No questions? Most of the time going forward is not a problem. It's only when we start to return, then we can start to have confusion because we are returning to a value to what? And when do we evaluate the multiplication? So those are the questions that we'll have later. The other thing that is important is you can see that I do not indicate 3 times question mark because even though this n is actually referring to this n here, I do not say anything about it. Okay? So we defer the references to variables and parameters until we actually need to perform the operation, but not anytime sooner than that. Okay? So the invocation of Factorial as a result of executing line 4 will get us back to line 3 because that's the beginning of the Factorial subroutine. Line 3 is now comparing n, which is 2, to 1. That is still true. So this is also when I will start to use this trick here. So we can just kind of focus on the columns that are important to us at this point. In fact, I can make this a little bit further like that. After line 3, we get to line 4. Line 4 is doing about the same thing. So since we are invoking Factorial again, we need to return info. And we also need a column for n. And this time it's going to be 2 minus 1, which is 1. And return info is still saying we are going back to line 4. When we do get back to line 4, we have 2 operations to perform. One is the multiplication, and the other one is the actual returning. And that's how we set up the 2 columns. Are there any questions at this point? As I said, going forward is easy. It's going backwards that can be a little bit confusing. After line 4, we are going to the beginning of the entire subroutine, which is line 3. Line 3 evaluates n, but this time n is column I, which has a value of 1. 1 is greater than 1 is false. So finally, we don't do the recursion anymore. We are going to line 6 to stop the recursion. Line 6 says return 1. Return 1 will go to the rightmost return info cell, copy and paste it, and change the question mark to the value that we are returning. That's all that it's going to do. It's not going to compute n times 1. It's not going to say, oh, n is 1 or n is 2, so n times 1 is just 1 or 2. No, we do not perform the multiplication. This is not the right time for the multiplication. We just replace the question mark, and that's it on line 6. After line 6, we get out of the conditional statement onto line 8. Line 8 has 2 things to do. 1 is to tell us where we're supposed to go back to, and then 2 is to deallocate the columns for this particular invocation. So what we'll do is I'll just copy and paste the entire return info cell. So this way it is very clear what we are doing when we get back onto line 4. And I have to change this accordingly. Okay, here we go. Are we doing okay so far? After we indicate where we're going back to, we have no use of these 2 columns anymore on line 8, and as a result they are deallocated like that. And now we continue execution on line 4. Column H and column I are now deallocated, which means now we are using column F and column G, and we are executing line 4 the way it is specified here. Okay, so we first have to evaluate n times 1. Which n am I talking about? Which column are we talking about? We're talking about column G, because column I is now gone. It's not a part of the context anymore. So n is referring to column G, which has a value of 2. 2 times 1 is 2. So we are returning a value of 2. When we return, so this is basically saying return 2. What do we do when we execute a return 2 statement? We look up the rightmost return info cell, copy and paste it, change the question mark to the value that we are returning. Column F is the rightmost return info cell, copy and paste it. And what value am I returning again? We're returning a value of 2. Now this part gets confusing because F16 as a cell is the result of executing B16, which is the statement that I'm executing right now. Okay, it is confusing because they're both saying line 4, okay? But if you think about the concept, it is not confusing because one is a return info cell, which has a question mark that needs to be replaced. The other one is the action, specifying the action to replace a question mark. Okay, are we still doing okay so far? Does everybody understand the cause and effect of this row 16 trace? Okay, so I'll say that one more time. This is the result of executing this. So F16, having the question mark changed to 2, is the result of executing what is specified in B16, which is the result of having the 1 resolved because that's the invocation that was resolved earlier. Once we have executed line 4, there's nothing else that we have to do inside the conditional statement. We continue execution on line 8 in this case. Line 8, once again, has 2 things to do. One is to remind us where we are supposed to go back to. Return info will remind us where we're supposed to go back to. We just copy and paste the entire F16, cell F16 to here, because this will be our next statement to perform. After we make use of the return info cell, we have no use of these 2 columns because the invocation is coming to an end. So we mark these 2 columns as deallocated, and now we continue execution here. Column F and column G are now not available, so our context is now back to column D and column E. And we're executing return n times 2. Which n am I talking about? Column E. Column E has a value of 3. 3 times 2 is 6. So effectively, we are executing a statement, return 6. When we are returning 6, what are we going to do? Just like any return statements, we locate the rightmost return info cell, which is column D in this case, copy and paste it. Change the question mark to the value that we are returning. In this case, the value we are returning is 6. Okay, so that's get replaced with 6. And that's the only thing you do with a return statement. It only replaces a question mark. It doesn't do anything else. This is not the right time to do the printing. All we are doing is, oh, since you asked me about the question, I'm answering the question. I don't care what you are going to do with that answer because it's not my job. After line 4, we get to line 8. Line 8, once again, has 2 things to do. Look up the return info cell so we know what we're supposed to do after this. And then we have no use of these 2 columns. So we mark these 2 as deallocated. And now we are ready to continue execution on line 10. Line 10 is now just simply print 6. So in the comments column, we just say, a value of 6 is printed to the screen or the output or a file. It doesn't matter. And then after line 10, we get to line 11. line 11 is the end of a subroutine. We look at the rightmost return line number. In this case, it tells us that we have to continue execution at post. And once we use that column, we have to deallocate it because it's not useful to us anymore. And then we continue execution at post, which means we are now done at the end of the entire algorithm. So are we doing okay so far with this? Because this one definitely is a bit more complicated. It has to do with having the invocation on the very same line as the return statement. Is that okay? More or less? No?
Can you scroll back over to so I can see column F on the right hand side?
Absolutely.
I just want to see.
In fact, what we can do is we can show the entire sheet.
Yeah.
And not use the split. Here we go. Are we still doing okay, or are there any specific question about this trace? In terms of the representation of the logic, do you think this is a shorter and more concise representation of Factorial? Okay. In terms of the trace, it is complicated because the most difficult part is to look at row 16 of the trace and go, okay, what am I doing here? I have the same thing, almost the same thing in column B and also on column F. So you have to understand it is executing the one in column B, the results in the one that is on column F. That's the most important part. Yep.
Could you summarize the execution of the line 6, the return value?
So I just want to ask.
Line 6?
Yeah. Could you just summarize that? Executing line 6?
You mean row 6 or line 6?
Yeah, row 6.
Yeah.
So you're talking about this row?
14. Yeah, that's what I was awesome.
Okay, so this is the result of executing line 10. Okay, when you go back to the algorithm, line 10 is saying, figure out what is the factorial of 3, and then I'll print it out. That's what line 10 is saying, right?
I wanted row 6, sorry.
Oh, you mean
Return value. Just do a return. Summarize it doing a return value.
You mean this line?
Yes.
Okay, that line is executed when we execute line 6 on rows 14 of the trace. So whenever you return a value, what you're doing is you're looking up the rightmost return info cell or the current return info cell. Just copy and paste the whole thing, because the only thing you really have to do is to replace the question mark with the value that you're returning. So in this case, because the return info cell looks like this before, by saying return 1, I'm just replacing the question mark to a 1. It looks complicated because we are copying and pasting the entire cell and replacing the question mark to the value that we are returning. But that's all it's doing. A return statement is just changing the question mark to a particular value. That's all it's doing. Is that okay?
Yeah. It's two things just like the other ones. Everything's basically 2 steps. Locate the rightmost return
Info in this case.
and then replace the value.
Replace the value. Exactly. That's the whole point of a return statement, is to change that question mark, which is representing a placeholder in some other context, by a particular value. Is that okay? Are there any questions about this trace? Because this is a kind of more complicated example of using a return value.
I think the only problem I had was with what you just went over. 'Cause that's just like, right, it all seems smooth until there, and that's when it changes. And I got everything besides that. I think that's all the tricky part.
You have to go back to the earlier examples, because the mechanism of the return statement has not changed. It is consistent from the very first program that we talked about today to here. The return statement is still doing exactly the same thing. But the context has changed. where the return statement appears has changed. And the invocation statement also changed in this case. So the complicated part about this program is the utilization of the invoke statement inside the return. Now, if these two lines were separated, the program would be a little bit easier to understand and trace. So I'll give you an alternative version of this program just so that you can trace that one and make it kind of connect the two, okay? So what I'll do is I will save this file again, but change the program just a little bit. Okay, so we'll just call this alternative. And what I'll do in this case is I will artificially introduce one local variable. And we'll just say this is local x here. So instead of returning, having an invocation on the same line as a return, what I'll do is I would use x as a buffer in between. So I will say x gets invoke factorial n minus 1 goes to n. And then on this line, instead of multiplying to the result of an invocation, we'll just use x here. So the change is fairly minor. I'm just using a particular local variable to do pretty much the same thing as a return value itself, but it does separate the original line into two lines, okay? Because I'm using x to connect the invocation of factorial to the return statement. And you will find tracing this one is a bit more easy and also more intuitive, because you don't have to deal with, I'm executing a return statement to specify a question mark in another return statement, because now they are two separate things. But you have to kind of trace this one and kind of mentally connect this program with the more concise version and say, okay, so x doesn't really do anything useful because whatever I put into x, I'm utilizing it right away. So I'm just combining line 5 and line 6 in the previous program. So I think this will be helpful, okay, for people who are looking at this and go, okay, I kind of need to know a little bit more than just how to deal with a return, how to deal with an invocation on the return statement. This is a good way to look at it. Let me clear out sheet 2 because all this stuff for the most part they do not apply anymore. So let's go ahead and get rid of all that stuff. Yep.
What kind of area would this program be used for? What application used it where it's just continuing to reduce the number until it reaches a certain point?
Why is it useful?
Yeah.
Because certain numbers are easier to express this way. It may not be the most efficient way to compute it, but it's easier to express it this way. For instance, if you want to figure out what is the total number of bytes used up by a folder, then you have to add up all the files in that folder. But if that folder has subfolders, you have to apply the same thing to the subfolders, right? And then what if that subfolder has a subfolder? Well, we have to do the same thing. So a recursive algorithm makes the logic look a lot more clear. There is a way to express the same logic, but without using recursion, but it would not be as intuitive because you'll be looking at really artificial constructs to emulate what we have to do, what we can do natively in recursion. You have to do extra stuff when you turn it into a non-recursive algorithm. In fact, I think this is a good opportunity. This is a good homework assignment. So that's exactly what I would do, is to turn this into a homework assignment. The easier version, not the complicated version. So I'll turn the easier version into a homework assignment. So save, and I'll turn on the track changes. Because I want to see how you guys do the editing, whether whether it's common for people to make a mistake on their way into the subroutine or when they're on their way returning back. Because I think it's the returning back that is more tricky. Going forward is not too tricky. It's the returning, how do we get back to the original line that is tricky. So I turn this into a homework assignment and just upload it to the website. because we haven't had a homework assignment for a while. This would be a good time for that. And lazy, yes I am. I'm gonna pick up. I'm just copy and pasting the instructions. I'll just call this Factorial. Unlink, link it back. To make sure I give you the alternative, because the other one is done already.
Fine with that one.
Okay, download this file to a folder, do not click it open, blah 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 blah. Yep. Save the file first. Okay, so the rest of the instructions still applies. And we'll make the homework assignment due 1 week from today. And we'll make it due at the beginning of this class. Yeah. So you can get started right away. Always show description, notified rate here. File submission, yes. Maximum files, size, submission comment, feedback comment, turn on. 20 point. It is homework. Oh, not. Okay, we'll click into homework. Right. So now you have your homework assignment. Now, if you want to review, you can review this in two ways. You can watch the video again, or you can remind me to upload the files that I worked on today. Just looking at the files, may not be as helpful as watching the video, because you can actually see how I do it step by step and actually the explanation. A lot of this stuff is actually repetitive. Okay, it's, as you probably have noticed now, there's a lot of repetition. Anything else? Anything else about return values that you guys want to talk about?
Could you upload the file that you did today? That way when you do the videos, I can follow along with the file.
Yeah, I can do the file thing. Yeah. So if you guys don't have any additional questions, I'll just kind of end today's class a little bit early, and I'll see you guys on Thursday. So at least give the homework assignment a try before Thursday. So if you have any questions, we can talk about that on Thursday.